thanks, Andy, and welcome everyone to Spark Summit East. It's really exciting to be out here and to see so many people here in New York. So welcome again. I'm excited to talk to you today about Spark 2.0, which will be the next major release of Spark. And before that, I'm going to talk a little bit about what happened in 2015. So 2015, as I think a lot of people are aware, was a really, really great year for Spark. And a lot of the numbers in the community, a lot of the use cases have gone up very significantly. So just some statistics from 2015 compared to the year before. Just the attendees to Spark Summit almost quadrupled. In 2014, we had our second Spark Summit actually in San Francisco. We had around 1,000 people. And in 2015, we went to 3 locations, including New York and Amsterdam, and we went up to 4,000 total attendees. The number of meetup members in smaller meetup groups throughout the world has also increased dramatically from 12,000 at the end of 2014 to around 60,000 at the end of 2015. And finally, something I'm really excited about, the number of contributors to Apache Spark has also grown. So at the end of 2014, there had been 500 total contributors to the project. At the end of 2015, in December, we hit 1,000. And that means there were 500 new people who contributed code to Spark in 2015. So I'm super excited. Let's give them all a round of applause to everyone who's contributed. Yeah. And it's a great milestone for the project, and I'm sure that we will continue this growth. And to show just one snapshot of this is a map of all the meetup groups that existed at the beginning of last year, on meetup.com, and this is a map at the end. So we also open meetups in a bunch of new continents and new places. And this is, we still see a lot of new meetups starting, every week. In the code itself, we got a whole lot of new components produced last year and released, including things like DataFrames, Project Tungsten, Spark R, machine learning pipelines, and lots of new features that people are starting to use right away. One of the things that's really exciting for me as one of the developers of Spark is seeing how quickly people start to use these new things and give feedback on them. Okay, so I want to talk, though, about Spark 2.0, and this is going to be the next major release that we'll make. It's slated to come in April or May, depending on how things line up. It's somewhere around the end of April, and it builds on all the stuff we learned in the past 2 years. So this is, even though it is 2.0, it's not like a revamp of the whole project, but it is a chance to tie together some loose ends and also to add a bunch of really nice and significant features. So because we had so many features coming in this release, we decided to make the version number 2.0. So just so you understand how versioning works in Spark, this is how it's set up. So you have your version number with 3 pieces. There's the major version. The main thing about major versions is that they may change APIs, although we don't like to do that usually. But this is what that is. There's the minor version. This can add APIs and new features, but it can't break the existing ones. In fact, we keep not just API compatibility, but binary compatibility with the past release. And then there's the patch version. This can only add bug fixes, no new features. So in reality, even though 2.0 is a new major version, we really hate breaking APIs. You can ask anyone who's worked with me on Spark how much I push back on this. And it's because, as a user, the worst thing is when you have something that works and then you upgrade one of your packages and it stops working. And, you're just stuck. You can't do anything about it. So in 2.0, we're not just going to break, lots of APIs. We will change a few of them, but in some pretty rare cases where they cause dependency conflicts. One example of that, if you're familiar with the Java API, is the use of Guava, which is the Google Collections library. We use it for one really uncommon thing, which is options. And the option class in Guava, even though it's a very simple class, if you're a programmer, it's a collection with either 0 or 1 element, that is not backwards compatible across versions of Guava, so we're getting rid of that. But these are the kind of changes that will happen. So hopefully for most users, the update to 2.0 is not going to be, is not going to break their code. So what are the actual features? There are lots of features coming in the release. I'm going to highlight 3 of them that I think are the most important. And these are first the continuation of Project Tungsten to speed up Spark, especially the structured data part of Spark. And we have some really cool optimizations that are landing in this release that will give speedups of 5 to 10x for some really important uses. Then we have structured streaming. This is a higher level streaming API, similar to DataFrames, similar to Spark SQL. It's built on the structured data engine in Spark. And the other exciting thing about this is it's really meant to push Spark beyond just streaming to a new class of applications that do other things in real time. They don't just analyze a stream and output another stream. And I'll talk more about that later. And finally, we have unifying datasets and DataFrames. This is the most technical, but it creates a really nice foundation in the future for the growth of the project. So let me start with Tungsten sort of phase 2. So just a background on Project Tungsten, if you're not familiar, since Spark was released 5 years ago, hardware has changed a bunch. And the main thing that changed is that CPUs aren't really getting much faster, whereas I/O has gotten much faster. So in a lot of big data applications, the bottleneck used to be the network or the storage, but now it's increasingly the CPU. Now, how do we improve that? We want to make as large part of Spark as possible execute really close to bare metal, same way as native code. And basically, there are 2 pieces. There's native memory management, which bypasses the Java VM. And there's runtime code generation. For a lot of high-level libraries, we generate expressions that will, that will run fast on this native memory without creating lots of Java objects. So Tungsten came out last summer in Spark 1.4, and since then we've been adding basically just this binary storage layer and basic code generation, which did provide a whole bunch of speedups as well as improved robustness for large memory workloads. And we also added 2 APIs, DataFrame and Dataset, that let you use Tungsten in user programs. The key idea in these APIs is, normally in the Spark API, you just had a bunch of Java objects floating around, and there wasn't that much we could do to optimize or to change the representation. In these APIs, you get data with a known schema, and even though you can have a shim on it that looks like Java objects, which is the Dataset API, we control the storage underneath, and we can do much more efficient execution for a lot of operations. So it's also used in Spark SQL and parts of MLlib. So what's coming next? So in 2.0, we have 2 really big optimizations. There's actually a talk about these later today from Nong Lee, so you can get a lot more detail. The first is whole stage code generation. What this means is it removes the iterator calls between different operators in Spark. And basically, if you do a bunch of operators together, like a map and a filter and a group by, it fuses them all into one snippet of code that's optimized to do just these 3 operations, and that doesn't have any virtual calls. That leads to some pretty significant speedup. So here's like a simple example of a benchmark. This is just processing data once it's in memory in Spark, and with a simple SQL query. And this improves by almost a factor of 9 through just better code generation. And the second thing we're optimizing is input and output. We found I/O both from Parquet and from the columnar cache built into Spark isn't always the most optimized. And with a little bit of work there, actually I should say a bunch of work there, we're able to make that quite a bit faster as well. So Parquet is the on-disk format we're focusing on at first, but the same things will apply to ORC and other formats in the future. And it's also about a factor of 9. And the really cool things about these is you don't have to change anything in your programs. It will automatically apply to SQL, DataFrames, datasets, MLlib in many cases, anything that's built on Tungsten. So that's one of the things. Check out Nong's talk on optimizing Spark this afternoon for more details. Second thing is structured streaming. This is one I'm really excited about. This is more on the new API side, but it does some really cool things. So basically, we see real-time processing is increasingly important for a lot of Spark users and big data users in general. But what we discovered, talking with users of Spark Streaming, is really most applications don't just need to do streaming. They're not just like, oh, here's a stream, apply a map function and get another stream. Really, the most interesting applications and the most important ones combine it with other types of data analysis, including batch and interactive queries. And this is a thing that current streaming engines don't really handle. They're just built for streaming. They're just like, give me a stream in, I'll give you a stream out, that's it. So just examples of other types of applications. A super common one we see in pretty much all users of Spark Streaming is I want to build up or track state using a stream. For example, I want to track sessions of users on my website, and then I want to run interactive queries on this state because it's real-time data. I have real-time questions to ask about it. But this is a combination of streaming and interactive that isn't really handled by current streaming engines. You have to put the data somewhere else and query it, and it becomes very operationally complex. Another example is I train a machine learning model offline, and then I want to apply it to a stream or even update it using a stream. And again, you need an ML library that works across these things, and maybe a system that can go back to the offline portion. So Spark is obviously very well suited to do this because it supports all of these types of computation. And in structured streaming, we are also looking to make them super easy to combine. So what is structured streaming? It's a higher level streaming API that's built on the Spark SQL engine, as well as a lot of the ideas in Spark Streaming. It's a declarative API that extends DataFrames and datasets. So that means it can run over Tungsten to get all those optimizations. It can do a lot of optimizations on its own, like logical optimizations that you'd get there. And it has a bunch of higher level features than you currently have in Spark Streaming, such as event time, out-of-order data can be handled using all the operators, windowing, different types of windowing, very easy to create sessions, and a really rich API for data sources and sinks. Many of the same things that make Spark SQL easy to use. But on top of doing streaming, it also supports interactive and batch queries in a way that no other streaming engine does. And for example, you can do things like aggregate the data in a stream and then serve it using the Spark SQL JDBC server and just have ad hoc SQL queries that act on the latest state. It's super easy to do that with Spark. You can change the queries at runtime. You can add queries, remove them, and so on in this engine. And you can also build and apply machine learning models. And we're making most of the libraries in Spark interact with this in both the batch and streaming settings. So really the idea we want to do here, and we'll talk about this more, is we don't just want to do streaming. We want to do what we're calling continuous applications, which is an end-to-end application, including, say, something that reads a stream and then serves queries off of it. And there isn't really any single platform today that does that. So that's why I'm excited about that. Just to give a really small picture, here are some things you can do with structured streaming. So classical streaming is, you take in data from something like Kafka and you do maybe ETL, extract, transform, and load, basically a map function or a group by, and you stick it into some other system like a database. Or sometimes streaming is about, okay, you do ETL, then you build a report, and then you serve it to some applications. With structured streaming, you can also do the following. You can just do ad hoc queries on the same stream. No need to put it in some other weird storage system and worry about consistency among those. So this stuff in orange is other processing types that isn't traditional streaming. And likewise, you can train, say, a machine learning model, maintain it. That might involve running a batch job once in a while, and then serve it, apply it back to a stream. And again, it's very hard to do that with a purely streaming engine. So basically, the goal is to have these end-to-end continuous applications. So how can you find more about structured streaming? I'd love to talk about it more, but I don't have time this morning. So Spark 2.0 will have the first cut at this, which will focus mostly on ETL, but it will lay a lot of the groundwork for the other things. So hopefully you'll get some of these other features too. Later versions will add more operators and libraries. And Reynolds' keynote tomorrow morning will be just about structured streaming. And Michael Armburst also has a talk later tomorrow with even more details. So I hope you stick around for tomorrow to hear about this. Okay. And the final thing I want to talk about is datasets and DataFrames. So these two APIs, if you're not familiar, they're pretty new, but they're pretty exciting. We added these APIs as ways to work with structured data in Spark, mostly to enable the Tungsten engine underneath and to enable us more control over memory layout and execution so that we can get really fast execution on all the hardware coming out in the future. So data frames are collections of rows with a schema. They're sort of dynamically typed. They're like the data frames you use in Python and R, so really nice for like scripting, but maybe not, not that great for building large complex programs. And then data sets, which came out in 1.6, add static typing. So you can have a data set of, say, people, and you can view it as Java objects, but things just get converted to Java objects when you act on them. Underneath, they're still represented using the binary format in Tungsten, like data frames. And obviously, both run on Tungsten. So in Spark 2.0, the main thing that we're doing is that we will merge these APIs. Both APIs were marked as experimental, especially dataset. It was still pretty new, but we think we've gotten enough experience to, to actually combine them and finalize them. And by merging them, basically a data frame will just be a special data set of objects of type row. But it's really nice to merge them just to have fewer concepts for users and libraries to worry about. So an example of how you might use this, say we have a bunch of classes in Scala. Same thing works in Java and Python, actually, very similar APIs. Like we have users with a name and ID, and we have messages with a user in them. So you can load a lot of Spark's input methods bring you a data frame. So you can load a data frame, say, as JSON, and this is actually a data set of row objects. And if you want to view it as message objects, you can just say dataframe.asMessage, and then we'll match the fields of the message class with the fields in your JSON schema, and suddenly you have static typing. You can pass this around, and like your code knows what type it is. So you get all these benefits of software engineering from static typing. And then you can do operations on it. It looks very similar to the RDD API, and they all look like you're acting on Java objects. So for example, you can filter the messages, you can map it to users, and you get back new data sets with new types in them. This is the one part that's different from the current data frame API, and that is like a small API break. Currently, map on a data frame gives you back an RDD, and we're changing it to give you back a data set. So this is like the one like small thing that we have to fix in here. But the benefit is really nice because now this is all kind of unified. And finally, all the libraries in Spark can increasingly take data sets as input. So MLlib, you can pass your ML pipeline just a data set of users or messengers or whatever you want, and it's all set up in terms of these. So it's a really fast way to move data between different libraries. So that's what we're doing. So benefits, it's a lot simpler to understand. In fact, the only reason we didn't do this change when we released dataset in 1.6 is because we wanted to keep binary compatibility. So we couldn't break parts of the API, like the map part I talked about in the 1.x series. But we can do it in 2.x. Libraries will take data of both forms. So when you write a library like MLlib, you don't need to worry about like what classes the user is using, as long as they describe their stuff in a schema you understand. So that's pretty cool. And with streaming, we think, I was told it's 98.2% sure that we'll use the same class data set to represent an infinite data set or a stream. So actually the same API, as long as you stick to the parts that also work on streams, will work on streaming. And it's really cool because you can test your program, locally on static data and then just run it on a stream. It's again something that you don't see in other streaming systems. So this will come out in 2.0. So long term, RDD will remain the low-level API in Spark. If you want full control over how your data is represented as objects, what code you run, and all that, RDD is the way to do it. And datasets and data frames give these richer semantics and optimizations. And new libraries in Spark will increasingly use these as the interchange format. So as example, structured streaming and MLlib are already using them. Another talk you'll see, this is in the research track today, is a research project between MIT and Berkeley called GraphFrames, which is a graph API based on data frames and SQL that also uses these. And I think we'll see other ones as well. All right. So this was really kind of a whirlwind tour of some of the top features in 2.0. There are a lot more things coming, but I hope it gives you an idea of what to be excited about. And all these things I mentioned, there are detailed talks about them later on today and tomorrow. So I hope you check them out. So thanks again for coming out to Spark Summit East, and we hope you enjoy the rest of the program.